All right, I think it's live, and we do need to do the test today because I'm trying a different microphone. See how big a
All right, I think it's
disaster it
live,
is.
and we do need to do the test today.
It does sound okay. Yeah. Anyway, don't really need another microphone actually, but I can have separate microphones for the computers, which is nice. Don't have to keep moving things around, maybe, and maybe effect-wise, do some effects or something. Anyway, yeah, here. Subject. Yeah, it should be working okay. Get out of my way. Get out of my way. All right. I guess we can bring this down a little bit. I've found I can just use this little. I can't really hit it because I can't see, but get rid of that way. Might work better. So I think I might do some drawing here. I think. We'll see how it goes. All right. What I wanted to talk about was mass and charge and force, because these are all like words that are just people make a mess out of them. So eventually I'll make separate videos on each one of these subjects. So I was watching the David D. Hilster guy, who again I'll point out I like personally. I just I just don't like his physics much. And this is the way life works, I suppose. I don't. You'd think, in some ways we should be able to communicate our disagreements with each other, let's say. And maybe we can do that. Maybe we can find some way for me to explain to him why I see huge flaws in his particle model, and he can explain what he sees as the huge flaws in mine. We sort of got a little taste of that just because everybody's always glued to some sort of foundational perception, and his is this whole affinity thing, and, people all the way down. I mean, these people have a view of this fractal idea, this idea that the universe does the same thing over and over and over at all these different levels, is, in my opinion, just so fundamentally wrong, because, that does lead to the Horton hears a who kind of nonsense, where, and I just don't think there's any evidence that the small universe is doing any of that. And I don't think there's any evidence that the big universe is doing anything like that. So, it doesn't have any of the obvious mechanisms that we see to compare. I mean, it just has some round things in common. We don't even know how round the little universe is, actually. So that's sort of cheating, because it could be all squares. Anyway, so yeah, I just foundationally we disagree. And, but anyway, let's just start from someplace. And so there's these words people use like mass. And I would argue that to understand mass, you have to understand force. Because you have to understand the two things are different. The stuff moving the speed of light doesn't have mass. That's why Einstein's wrong, and it's not bent by gravity. Because it's not mass. It can't interact with force. Force can only interact with certain things, and that's it. And so there's, as I've sort of put it, mass bits or matter bits and force bits. So maybe that's a good way to say it, is mass bit, instead of strangling or being tortured by jargon. Just establish that there's, these two kinds of bits, the electron bit, and I suppose we could draw the other one, but I don't know if it's necessary. For this purpose, let's just say that's an electron, and there's the equal component, not exactly the same, but similar component of charge, which would be the proton. Well, I guess we might as well draw it because it just doesn't the same without it. Here, I can just lower that a little. But then I still have to do this silly thing, or hit the enter key. So maybe I have to learn how to hit the enter key. All right, so you have electrons and you have protons. Okay, make it a little bigger. And you get this idea that there would be I would argue, a geometry of their position. So the electrons all position themselves. Let's see, I wonder if I can copy this thing as a node. No. Let's see if I can select it as an object. Apparently I can. And then I could probably copy it and then paste it, right? Let's see. Should we try something like that? Yeah, it's a little dangerous, probably. Paste. Let's see what it does. It didn't paste shit. Okay. I didn't think that was going to work. Yeah, no, I didn't think so. Maybe if I do that and say paste, it'll paste, but I doubt it. Yeah, still didn't paste it. All right, so anyway, never mind. So these are the matter bits, and then we'll use arrows to indicate the the fact that there's force. All right, and as stated, there's two kinds of force. There's the red force, and then there's the black force. We'll be using black force mostly, I think. Oh, I gotta find a better way to do this. All right, so the arrows will just indicate force bits. Now, the force bits can be in the form, as stated, of gravity, or they could be in the form of there, that's better. We can make big fat force bits. Or they could be in the form of light. So at a frequency, so when there's little force bits at a set frequency, set distance from each other, we call that light or electromagnetic radiation. When the bits aren't at a routine frequency, it's gravity, and when it's mixed, it's gravity. Red and black. And when you segregate it, when just black is heading out one side and red is heading out the other, then you have something called magnetic. All right, well, anyway, so the idea is the only thing moving are these force bits. So there's a bunch of this little stuff in the universe moving the speed of light. And when these little bits hits an electron, it bounces off, essentially. It reflects. But what it's really doing is exchanging. It's going to give the world back one of those, going that way, a little force bit. And in a sense, it's going to, for that exchange, it's going to keep one, and it's going to give back another. So the one that was going in is still in here. So it's just kind of stuck inside. And it's still part of this electron. So this electron's going to move. And it's going to move proportional to whatever we decide this mass thing is. Now, I could argue that the electron has no non-moving mass. And when it's not moving, it doesn't have any mass either. And it's only when it's moving, it has mass. But the point is that it does interact. So the force hits it, it does move. So it's a thing in space, these things that have mass, protons and electrons. Now, neutrons are just a proton and an electron. So let's understand that would be my argument. So the only two matter things, the only two things in the universe that have mass, that is, they can be hit and move. The proton has to be hit by red arrows, just understand that. And if it's hit by a black arrow, the black arrow leaves perpendicularly. So these are the sort of the rules of motion. So the electron moves, and by moving, if there's another electron, somewhere around, it'll end up getting closer to that other electron. So you can understand if there's another electron here, close enough. Or you could put them in the same place, Gary. I could. I wish I could. I mean, I should be able to move these things, but they just don't seem to want to do that. Hey, that moved. Great. Thanks. Move the thing I didn't need to move. Okay, there, moved it. Oh, that's much better. All right. All right, so there's another electron. Come on. Quit selecting things. I don't want selections. It takes a little time. Anyway, so the electron moves. And if there are force bits between those two electrons. Those electrons now, obviously, those force bits are going to be banging into the electrons more frequently because the electron is moving towards the other electron, and that creates pressure. So you can sort of understand that that's more arrows hitting the opposite way against the electron's motion, and so it's going to make the exchange the opposite way if the pressure is too great. So the idea is, all right, so I don't want to get to conductors and all that crap yet. Not too bad. Yeah, it's just too bad. You didn't want to do something. What a surprise. Anyway, so yeah, I'm just making a mess out of this. And I'll say something like, that's not my fault. Yeah, now I got this thing again. I don't want that thing. I want this thing. All right, so if you just imagine that in a conductor, these electrons are all in a row. So when you hit one, you essentially hit them all, and the pressure moves right along very quickly. So that's the idea of what's happening in a conductor. A conductor basically is just saying we have a lot of these electrons in a row. Now, the trick would be if the conductor is kind of crappy, like the atmosphere, there might not be a great row of electrons. And the places where there's gaps, you could imagine that it'd get a little messy with this force flying about, and the force ends up getting loose. And that's when you have light, photons produced. So electricity will produce photons when the electricity, which is the force, the little force bits, that's what's creating the pressure, the voltage, gets loose. And getting loose just means the electrons are out of order, or there's some other reason. But anyway, the pressure between them ends up escaping because they don't have a nice, consistent geometry. And you can really see that with lightning. I mean, geometry is all over the place. Of course, a bunch of force is going to get wasted. It's not going to get to the ground. It's going to get irradiated into the atmosphere because there's going to be a lot of gaps in the conductor. All right, so that's sort of, I think, a useful statement to understand why things emit light. All right, now what did I really want to get to? So the David D. Hilster guy says there's no such thing as mass. All right, he says it's just a concept, just a word. And it's really not. The two things are different. Now, the arrow things I'm saying are particles. You could say electrons are particles, protons are particles. Yes, you can call almost anything a particle. But the word just really means corpuscle. Okay, you go back to Newton terminology instead of particle. I mean, it just means some kind of clump. But there's a big difference between a force clump and a matter clump. So what I would argue the truth is that the force clumps never interact with the force clumps. They only interact with the matter clumps. So two forces, two pieces of light can't hit each other. Gravity can't hit light. Light can't hit gravity. You can't bend gravity with light. You just can't do these things. The force is independent, speed of light. It's one kind of stuff, and the matter bits are another kind of stuff. And the real key to the universe is the interaction between the matter bits that have no innate movement and the force bits that have all the innate movement. So the force bits are moving the speed of light. That's the only thing moving. And the matter bits, you could argue, are like balloons, and the force hits them. So if you thought of it, I sort of gave this analogy. It's not terrible. So just think of a bunch of fish swimming. They all swim the same speed, and all the fish are the same speed. And there's balloons, bubbles, in the water. And the fish never hit each other, but they can hit the balloons. And when they hit a balloon, it absorbs the fish. The fish exchanges direction, so to speak. And the fish essentially goes into the bubble, becomes the direction of the bubble, and whatever other fish was in there, the opposite fish, is released. So there's a fish going this way. The fish goes into the, say there's a bubble here. Fish goes into the bubble, stays in there. and releases an opposite fish. So there's some other fish in here that you can release. And the new fish going this way is now in the bubble, and the bubble now has an unevenness. It has more fish going this way than it has going this way, so it goes this way. So the bubble moves. Now the bubble's getting hit by other fish all over the place, so it's constantly exchanging these fish. And that's the key to this whole thing. But it can only hold so much fish. It's got a limited number. And so it can only have a limited amount of say 5 stages to its acceleration. So let's say it had, there's some mass in the sense that the electron has some resistance to movement, but the resistance to movement is some percentage of the speed of light. So in a sense, you could say if it has a total of 10 fish, I don't know why this helps. There's a total of 10 fish, okay? 5 going this way and 5 going this way. You can understand that you could exchange all the ones going this way and then have 5 going that way. So then you have a total of 10 going that way. And that would mean you're going the speed of light. But if you have 9 and 1, that means you're going 90% of the speed of light. And if you have 8 and 2, that means you're going 80% the speed of light. See? So your percentage of the speed of light will be dependent on how many exchanges you made in one direction. So that's why you can accelerate electrons quite rapidly. You can accelerate them to you can accelerate them to very fast speeds very rapidly. But it's also why they lose their speed very rapidly, is because you only have to get rid of those 5 fish to stop them, to bring them back to their original condition. All right, maybe that works. All right, so, all right, now I've explained it on the website, but so we'll go back to the website, I suppose, for some sort of better image. So I just want to get to the idea that the force is the only thing that makes something move. There has to be force or there's no movement. And the stuff moving is the stuff we can interact with. That is, it has to be, I hate to say it has to be material, because obviously we interact with force all the time. It has to be able to affect our matter. Now, when two matter bits collide, the problem with that is, or interact with each other, is that they're surrounded by these little force fish that are always getting exchanged, and they're always coming out. So they always have fish going in, and they always have fish going out. That's the idea of gravity. So I've tried to sort of explain that. Maybe we'll do that with some arrows here. If I made chaos, let's do a new drawing. I don't know. This is something I got to put on the website just to, it's something I should draw ahead of time. That's the only thing I'm thinking about. All right, so you have a bunch of arrows going different directions. All right, so just get the idea that you have this field of energy that's just humongous. Okay, there's stuff going everywhere in every direction. And just for the sake of argument, it's in both colors, red and black. Now, as I've pointed out, the catch is if I take that random field and I just take any point in space in it, the trick is that from that point in space, all the energy that comes in contact with that point in space will look like it was heading right for it in this perfectly symmetrical way. There'll be no appearance of chaos. So from the perspective of a material bit, a thing being hit by force, this chaos doesn't exist. There's just a constant pressure pushing from all directions evenly. And that's a huge thing to understand of how simple it is to go from disorder to order. All right, go from a chaotic system to an incredibly ordered system. And all I had to do was stick my finger in the soup somewhere. I mean, I didn't have to do anything complicated. I just created a point. I just said, here's an electron. Here's something new. So you take this chaos soup, it's full of stuff moving in all directions, and you just put something that isn't moving in all directions, that has no motion, and you stick it in there in a place, and this happens. Everything all of a sudden gets incredibly ordered for that thing. From that thing's perspective, nothing is, you can't, just like you can't see the rays of light as they're moving, you can't see force that doesn't hit you. You can't know of it. You can only understand that it exists, but you can't interact with it. You can't personally know. So the only stuff you're going to personally know is going to seem incredibly ordered. It's just the whole universe is pointing the gun right at you and firing the bullets right at you. And so it's just I'm just saying as a step of enlightenment, as a stair on this staircase to understanding a physical mechanism. And it's just really important to understand how simple it is to go from disorder to order. All you did was stick your finger in. All you did was make a point in space, and you've created a tremendous amount of order. Now, as pointed out, is if I make two of these points, the problem will be these 2 points will start interacting with each other in the sense that they're all getting hit by this stuff, and the stuff is going through them and it comes out. So that's the other part to understand. It achieves equilibrium, however you want to think about it. Just like any other system, the amount going in will always equal some amount going out, or it has to get fatter and fatter and fatter, right? I mean, you have to eat and then you poo. You reach equilibrium with how much food mass you have in your body at any one time. There's a certain average, your equilibrium. And if you don't obey your equilibrium, then you would just get bigger and bigger and bigger and explode. Well, anyway, and so the stuff is always going in, always going out. And so the point would be is if 2 things are in proximity to each other, these 2 things will unbalance the relationship between each other. In a sense, this one will absorb more stuff going one way, and this one will absorb stuff going towards the other thing. And that's a real effect. It's a real phenomenon. If you build it, it will happen. If you build a box with a bunch of little BBs in it, you excite the BBs and then put 2 tennis balls in or 2 anything in, the 2 things will end up moving towards each other or the wall. They'll either stick to the wall or get stuck to each other. And that's just a mechanical consequence of them interfering with each other's. It's heading right for me. See, there's bullets heading right for me. If something's in the way of those bullets won't hit me. They hit, and so I won't get hit by bullets from that side. So you can understand there'll be a lack of bullets hitting me from one side, which means the other side will push me in that direction. It's that simple. It's a shadow effect. All right, and that gets into the nature of charge and magnetism and all of this stuff. So, but it's just a really, you can only understand this by understanding that these are 2 different things. The force and the matter are 2 different things. The point in space that's getting hit, the target, you have to make a target. And so mass is an example of something that's a target, something that is interacting with force. So anything that can interact with force has mass. Anything that can't interact with force doesn't have mass. Yeah, it's sort of that simple. So none of the force bits, none of the photons technically have any mass. They have something called momentum. They have the ability to move mass, but they don't have any themselves. You can't move them with a force. You have to move them indirectly by sticking matter in their way. Yeah. All right, let's see if I can Math Science. Should be the website. Happened to be. How lucky. So I have some of this idea written up, but it's not as illustrative as it should be. here's the idea of it's all heading right for you, and it's creating an internal pressure. So you're all getting pressurized by this force, and the tendency is to compress everything. And the real key to the charge part is this part. So this is so the Hilster guy first says there's mass is not a real concept, where clearly I think it's a huge concept in the sense that there's a huge difference between being affected by force and not being affected by force. Right. And the trick is that the mass bits, essentially, they can't interact with each other either, as pointed out, because this force stuff is coming out of them all the time also. So that's sort of the point I wanted to emphasize, is that force goes in and force is coming out. So the force they're shooting out is going to hit the other matter bit before the other matter bit can ever hit them. So they'll never really be able to collide. They'll emanate a force, the force will be reacted to, and blah, 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 blah. So they don't really bang into each other. But what they do in the concept of charge is they can change how close they can get to each other. So in the example of the electron and the proton, there's a low pressure created because the electron pressure leaks out of the proton perpendicularly. The proton pressure, the red force, leaks out of the electron perpendicularly. So you end up with a low pressure between them, a very low pressure. But it's not a zero pressure, because there's always bits coming in from the side that end up filling this gap, refilling it a little bit. So there's always some bits still moving this way. There's always still a red bit, a proton piece of pressure that heads for the proton. And there's always an electron piece of force that heads for the electron from the proton. It comes in from the side and ends up moving perpendicularly. So there's always some pressure. So they're attractive at a distance, but once they get to a certain proximity, they're repulsive again. So you have to kind of understand that that's the nature of charge. The charge does that a lot. There's lots of charge scenarios where you have a strong positive component and a weak negative component. And from different positions out here, you will sense that very differently. You'll sense it when you're close to the electron. You'll sense a very strong negative charge. But at a distance, you'll sense the very strong positive charge. And so it's just all about proximity. And so you're attracted at 10 inches, and you'll be repelled at 3 inches. And that's a real, and again, it's a real thing. It really happens in the real world. That's a real testable, reliable phenomenon. So, I mean, like I said, David D. Hilster is sort of saying, okay, mass isn't a real thing. Well, I think it has to be for a rational model, because you have to explain the movement of material things, because they don't have any innate movement. Their movement is entirely imposed by the external world. You have to accelerate something before it can have a velocity. And he also doesn't like the word charge. He doesn't think it's a real thing. But I think it's so fundamental to the function, to the whole idea of magnetism and electricity. You can't do those things rationally without recognizing the difference. And you have to have some explanation for that difference. And like I said, even conventional physics doesn't have an explanation, so everybody feels comfortable in just making up any kind of swirly crap because conventional physics doesn't answer the question either. But clearly the simple answer is that charge starts with the force. The force is charged. You don't see it because it's in the form of monopoles, but that's what it is. There's plus energy and minus energy. There's proton force and electron force. And the two behave differently and are manipulated differently. Like the entire electromagnetic spectrum, light, it's all electron force. That's why it affects electrons. It's because it's the force that's reflective to electrons. It moves electrons. Yeah. All right. It seems like garbage. The food has salmonella and E. coli. Don't touch it. I guess I'll just block you. I guess that's what you're asking me to do, right? Saying, please block me, right? Okay, so I'll do that. And then I don't know what this gibberish is. Are you serious? It's not the word serious. Goblin San.
Could be a new
I don't know
post.
what the hell that is. I don't know what this is.
Research.
Ligama meatballs in Mendem San. I don't know what that means either, so I think I'll just block that. That's just useless crud. All right, I don't know what Fred's up to, but I'll just let that float by for this minute. I guess he's commenting to the... I don't know who Goblin San is. Yeah, no, I don't know what he's talking about. So, as usual, commenters are of little use. Incredibly little use. Turn my speakers off. There. Okay. So what else do I want to accomplish here? I did want to get into a bit more, but like I said, I just have to make separate videos on each one of these subjects, and obviously those videos will have to be with writing and all of that crap. But I just wanted to assert why I think it's just unreasonable to start as a premise that the concept of mass, which is a real concept, and you always measure it using a force. I mean, you measure how much mass something has by throwing a force at it, seeing how much you can move it. And so you put one force unit and you push something, well, the one force unit might move a BB. It might cause it to roll, but it won't cause a bowling ball to roll and a cannonball. So you can judge the mass based on how much movement you get for putting in a little bit of energy. And it's a real thing. The mass is really just a collection of this stuff, these mass bits. And if they're in a collection, you have to move all of them to, you have to move all the atoms in the bowling ball for the bowling ball to move. It doesn't move unless you move all of the atoms. You can't just move some of them. And so you have to move a lot. You have to hit a lot of electrons and protons with force. And but so the mass is a real thing, and root of the elemental bit is this electron and proton, and the elemental bit is the fact that the force comes in the two forms of electron force and proton force, and that explains the interactions. And the one thing, the force, has the momentum built into it. It has all the energy, and the mass has all the all the obvious movement, in the sense that you can't see the force moving. You can only see things that are moving slow. And clearly the mass bits are the things moving slow, so we can see them. It's almost that simple. You seem very knowledgeable. So this book thing is just garbage. Did you read or learn all this stuff? You learn by, not taking anything you read too seriously. But I would argue that I learned through experience a lot of stuff. Just, I was a mechanic, and I worked in a machine shop, and I did electronics, and some computer science and different. So those things, I would say, I almost learned more physics doing those things than actually reading physics books. Now, you have to read physics books to understand some of this stuff about resonance and vibrations, and to learn some of the math and some of the concepts. But yes, physics is really bad at explaining mechanism or causes. It's really good at explaining Ohm's law or something, some way of understanding that there's a certain amount of resistance in a wire, and that resistance will slow down, the stuff moving through the wire, and cause both heat and light and magnetism, blah, 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 blah. So So, asking me to recommend something, I recommend, look, I mean, Professor Lewin's MIT videos are more interesting than most. So they're kind of watchable. He does demonstrations, so you see the experiment being performed, which is good. There's some actual visual aid. But it's really hard for me to tell you how you have to piece together your understanding. And a lot of it's going to depend on what kind of crap you get in your head. See, I mean, my advantage is I never bought the original explanation for photons. I always saw them as little bits separated by a distance. And so it gave me a way of seeing all the forces. I always saw gravity as something pushy. I never felt it as something pulley. So, and that's just it's a huge, you're removing the idea in gaining knowledge is to remove stumbling blocks, remove the banana peel ideas. There are ideas and concepts that are just toxic. That's sort of why I'm arguing this point with the Hilster, is it's toxic to pretend charge isn't a real thing. It's a real thing. It's happening for real reasons, and you can't just explain it away, like, it's just a concept, it's just a word. Now, it's a lot more than a word. It's describing a very specific phenomenon. And, a lot of these electric universe type people and hyperboloiders and whatnot keep thinking they can replace it because, if you stir fluid in the same direction, the beaters move towards each other. And if you stir fluid in the opposite direction, the beaters move away. I mean, it's, that's not going to explain what makes magnets stick together. It's not even going to be coming close to explaining it in any way whatsoever. It doesn't explain how the inverse square rule. It doesn't explain the intensity and the strength of the attraction. I mean, that attraction in a fluid is so weak. I mean, I can't even describe on what, it's 10 times to the minus 75 zeros or something weaker than it needs to be. It's not an explanation. And it's clearly made out of so much wasted energy that you'd have to say, where does all the energy go and where did it come from? And why can't we see any of it? I mean, it just doesn't work as an explanation. And I'm just saying that. It's very bold. If you're going to say there's no such thing as mass or charge, those are really bold statements, almost like the growing earth thing. He does that all the time. That's a really bold assertion, that oil is being created by the planet Earth, that it's not decomposed biological matter. That's an insanely, I would argue, bold assertion. That's like saying there's a Sasquatch. That's an extraordinary claim, and you really should have at least ordinary evidence. You can't just use one gimmick and say, look, see, it fits this one gimmick. One piece of the puzzle fits. And that's the only piece you should look at. It's the one piece that fits. Don't look at the 99 others that don't fit because of this, that don't make any sense. Like, how did the moon change its size in exact proportions to the Earth changing its size? Yeah, I mean, it just doesn't make any sense. Anyway, there are more positive or negative charge in the universe. Well, it's sort of obvious that I think you can kind of get the idea that it has to be in balance. If it's not balanced, there'd be evidence of the unbalance. So I would argue that the two have every appearance of being quite equal. That is, a magnet is able to manifest an equal amount of north energy as south energy. Very close. They say it's a little different. Like there's the attractive forces. The north side is a little stronger than the south side or some sort of bullshit like that. But I don't know how they test that stuff anyway. But I'm just saying to necessary precision, I think it's okay to say, yeah, the universe is balanced. It started balanced, and the imbalance is all just a matter of circumstance. in terms of the consolidation, the fact that the bits are being attracted by gravity. They're being locked together by magnetism. So once they're attracted, they get into positions. Those positions become push-pull. So the inside the atom, as illustrated, the protons and the electrons are in a balance with each other. They can't get too close, and the electrons can't get too close to each other, and the protons can't get too close to each other, except the neutrons facilitate that, by, I've sort of explained this. I mean, you can get two protons really close to each other by putting an electron in between them. And likewise, you can get two electrons very close to each other by putting a proton in between them. But the problem is, as soon as you start collecting electrons, then the electrons repel each other. So you can only have so many electrons in a circle because the electrons start to make the circle bigger and bigger and bigger. And that would sort of be the energy levels of atoms, but I don't want to get into that part yet. What really bothers me is why a neutron has no charge. Well, it does have charge. It just has both. See, if you have both charges, right, you look like you have no charge, right? If you're both black and white, you're black and white. You're neither one. So a neutron, when it decays into an electron and a proton. And then they say a neutrino, which you don't need, I don't think at all. But anyway, it's an electron and a proton. That's what a neutron is. So it's not that it doesn't have any charge, it's just that it has both. So it looks neutral, from a distance. Now, if you get close to it, then you could see where the electron was and where the proton was, and you'd see the difference. But from a distance, all you're going to see is gray, whatever, no charge. You're not going to be able to distinguish the two colors. So it only appears to be neutral, but it's not. The elements inside of it are not neutral. And, frankly, I wish I knew that like 7 years ago. I didn't know that was I didn't know neutrons decayed into protons and electrons. It's just so obvious that, well, obviously they're not neutral. They're obviously just neutral from a distance. I mean, atoms can look neutral from a distance, if they're balanced. And if they have a little bit of unbalance, then from, depending on which way the atom is turned, the atom can look charged or not charged. Just depends on which way you're looking at it. Turn it one way, it doesn't look like it has a charge. Turn it another way, it looks like it's charged. Yeah. So yes, neutron is really not a very good word. But there's not really another word to describe having both charges, right? I mean, it's di-charged, a ditron. You could call it a ditron. Something like that. Might work. My smoking stick. So, those are two big ones I want to get to. But yeah, you can't, like I said, you have conversations with people and they can't understand what you understand as being obvious and simple. So I say something like, the universe is made out of little bits moving the speed of light. To me, that doesn't need any huge justification. You're just saying that's the way the universe is. That's one of its simple rules. It has this crap in it. It's full of crap. It's full of dominoes. It's full of something. So, and that's what the something is. It's little bits moving the speed of light. Little sparkies, little whatever. It doesn't matter what they are. And that's what they do. They move from point A to point B at the speed of light, and they all have a certain amount of capacity to bang into something at a certain amount of, they're all the same. So little BBs or whatever. Now that seems perfectly acceptable to me. That doesn't seem extraordinary. Why should I have to defend that? Yet some ether theorist or something will say, well, where did that come from? Now, even though I could just say right to them, where did the ether come from? What do you mean? Why do I have to explain BBs bouncing around in a, universe. If you don't have to explain where ether comes from, why do I have to explain where BBs come from? But it's that ironic in the sense that they'll say my theory is broken right from its foundation because it has a moving particle in it, and yet they can create an ether, and they don't have to explain where the ether came. Where'd that pour into? What's holding the ether? Whose pitcher did it pour out of? What kind of Jello, flavored Jello is it? I mean, it just, so that's how bad things are, in the sense that, that's the part that just seems so much like religion. Like somehow Christians can't see that their religion is just as stupid as Mohammed religion. And the Mohammed religion people can't see that their religion is just as silly as Christianity. Somehow they think mine is so much more rational. Believing in Jesus is so much more rational than believing in Mohammed. And they have nothing to base that on. I mean, nothing rational at all. And, it's just surprising that they can be so belligerent in their belief that somehow, yes, Christianity is 1,000% more rational than Islam. And they just can't make a rational argument defending that. Well, you could just call it dark mass would be, again, lying, right? Because it doesn't interact. It doesn't reflect force. So I think I asked what my thoughts are on dark matter. If they made it into some, if they, I'm just saying they're making a mass bit that doesn't have any of the characteristics of mass, except it bends space, but it doesn't do anything else, right? So by my theory, obviously, if you reflect, if you absorb gravity, you would have to reflect photons. There's no way you could avoid it. It's just a fact. And yes, you don't have to react to magnetism because magnetism is gravity just filtered. So it's the same exact force. So you only react to gravity because you have the filter that enables you to react. To magnetism. You have to be a magnetic sensor to react to magnetism. But magnetism is technically just gravity filtered. But there's no reason why. There's no way you can create some sort of this idea of a kind of matter, electrons and protons, that don't interact with either the red force or the black force. It's just, you can't do it. It's not possible. Now, you could argue that if you made something out of protons alone, see, neutron stars, as I said before, neutrons are an interesting concept because you can theoretically think of condensing a bunch of neutrons, and that's mass. But yeah, you still can't make it non-reflective. So yeah, I know there's just no point. So obviously I think, well, anyway, it wouldn't even matter anyway. Even if you could theoretically come up with a way of making something called dark matter, clearly they're just using it as glue for their bad math because they put it in places that is completely irrational, right? I mean, in the galaxy, to fix the speed of the galaxy, they spread the dark matter like a halo. It's not spread inside the galaxy. They spread it like a halo, like a very specific halo, and they have no reason why it would be there, how it could stay there, how it either could be created in that location, or how it could sustain itself in that location without collapsing right back into the galaxy. There's no explanation for any of that. So it's like they're saying it has to be able to produce gravity without being affected by gravity. And what do you think the odds of that are? That you can make gravity, but you're not affected by gravity? I don't think so. Well, anyway, it's just made up. They have broken concepts, and they're fixing them with imaginary characters. It's just that simple. The puzzle piece doesn't fit, so they're making a magic puzzle piece, a joker, a wild card, so they can just stick that in instead. and say, there, eureka, we did it. They didn't do anything but cheat. Just cheating. They don't want to do the hard physics of having to come up with the right answer. So they just accept a silly, broken, wrong answer. And they've done that over and over. Like I said, the idea of saying virtual photons cause magnetism. There, we've answered the question. We're going to go off and have some fun. I mean, that's really lazy physics. And bending space, again, is just another simplistic, magical answer. No cause is necessary, no mechanism necessary. Yeah, we'll just make up a fake dimension and say it does this stuff without any energy. It does an energetic thing without any energy. But they kind of are doing hard physics. Well, I'm just saying I don't think it is, but anyway, with the Large Hadron Collider, they found new particles. Well, they actually didn't find much. They found the Higgs, and it's not really a particle. So again, you might argue that stuff has some sort of merit when it's based on notions that, in my opinion, have nothing to do with hard evidence. So they didn't find anything but a perturbation in their mathematical formula. They didn't find anything real. I mean, I don't know, it's so abstract from what you say hard physics. When I mean hard physics, I mean you can touch it, you can see it, you can deal with it. They're telling us that something that exists 1/1,000,000th of a second has a 1/1,000,000th of a second lifespan. They somehow took a picture of it. So with some device, they saw it somehow when we can't see anything like that. So it has no lifespan, and it's infinitesimally small, and you just take their word for it that that's what they saw, when they're only saying they think that's what it is. All they have as a reasonable statement is, our guess is that's what it is. But that's all. This little irregularity in our instrumentality. And they're just saying, I say that is A. And they call it a Higgs boson. But all it is a little squiggle. It doesn't, there's so little correlation between it's like me hearing a little sound, just a tiny bit of sound, and then telling you a whole story about what made the sound. Like there's a train in Oklahoma that just lumped on the track, and the vibration went through the track, and then it hit this weird building with a tin roof, and the tin roof vibrated, and the vibration from the tin roof, flew off the top, went out into the atmosphere and bounced off a cloud. And I mean, they have a whole story, and all it is just a little bit. They got nothing. No, it's not. I don't only believe in physics in which I can see and touch it. I'm just saying that it's a real thing. Storytelling is a real thing, okay? And so I believe in physics that isn't completely dependent on a huge amount of storytelling. So I'm saying, yes, there's a little sound. Let's pay attention. It's like the two-slit experiment. There's a pattern. Let's pay attention. Let's figure out what it is. Now, what are they doing when they see that pattern? Copenhagen, many worlds. They're coming up with all this extraordinary explanations. Do you see any evidence for any of those explanations? They've never proven a Huygens ever. They've never proven photons are a wave. They've never proven they do any of this stuff. Not a single bit of evidence. It's all just a story they're telling. Now, so I'm just saying I don't have to have hard evidence, in the sense you don't have to draw a picture, but your story has to have enough pieces of evidence in it for me to think you're going somewhere. You got to have you're going to say there's a snake, then you're going to have to show me a snake skin over here, and then maybe the snake pattern in the mud over there. You got to have more. It's like you have one claw print in the mud. You know what I mean? You're saying it's a bear and his name is Bobby the bear. I'm saying you need more than that. I mean, we can't even see if it's a bear. All we got is a claw. So you have to recognize that there's a thing called storytelling, and physics is doing a lot of storytelling. They're not doing a lot of proving. They're doing a lot of storytelling. Now, Maxwell's equations have there's no waves in Maxwell's equations. People just think there are, because Maxwell said magnetism is like light, and light they decide was electromagnetic. Well, no, it's a little deeper than that. But there's no waves in Maxwell's equations. There's vectors. There's straight lines moving at angles. But there's no waves in the equations. Just look how antennas behave. I don't even know how that could mean anything to a rational person. How does an antenna behave like a wave? I'm sorry. I mean, it radiates at a frequency. That is, it makes a billion photons that shoot out in all directions. Then it makes a billion photons that shoot out in all directions at a set frequency. How is that a wave? It's bullets at a frequency. It's a Gatling gun. You're basically just taking a bunch of cannonballs and put them on top of a bunch of TNT, right? And you could just layer them. Cannonballs, TNT, cannonballs, or you could just layer them with crap, just fluff. So you're just layering them, and you fire them, and then they shoot out into like a shotgun. A shotgun, the shot in the shotgun can be layered, and when somebody shoots it, it could appear to be coming at a frequency. You wouldn't call that waves of shot, But there's no waves in Maxwell's equations. Antennas take electromagnetic waves. Again, in what form? Electricity. How does electricity have to be a wave? It's stuff at a frequency. It's bullets. I mean, again, you're not going to show me anything that proves any experiment, any fact that in any way shows something waving, a photon waving, spreading waves, doing any of that stuff. It's always going to look like a corpuscle when you look at it. Feynman admitted it. All right? Feynman thought light was a corpuscle. He didn't think it was a wave. He thought it was wrong to teach kids that photons are waves. So, and he's basically the father of quantum mechanics. Electricity can be a wave. It's called alternating current. Again, you're just so distant from understanding anything. So you're saying if I throw baseballs, one a second, I'm waving baseballs. That's your opinion, right? It's proven fact. That's a wave of baseballs. You have no evidence. The evidence indicates baseballs landing at a frequency. The evidence indicates every time you look, the photoelectric effect, every time you study it or look at the target on the two-slit experiment, what happens? Oh, yeah, a whole photon hits a location. A baseball hits. Not a wave, a thing, a discrete clump hits a location. But this is the kind of thing. I mean, there's so much arrogance built into this. Oh no, they've proven wave. Maxwell. No, Feynman. I mean, look, again, it's kind of funny, right? Because he's saying, okay, electricity can be a wave. It's called alternating current. You don't have to alternate the current. Pulsed current would look just like a wave also. It's not. Alternating current isn't a wave. Alternating current isn't anything like a wave. Show me a wave that goes out and comes back again. Show me a water wave doing that. Yeah, and there's absolutely nothing spectacular about frequency. Absolutely nothing. You think the electron's going back and forth for no reason? No, the argument is there's a bunch of photons, a bunch of force holding the electrons together on either side of the electrons. So if you move force this way, and then you move force this way, what's going to happen to the electron? Oh yeah, it's going to go back and forth exactly at the same rate that you're pushing the force in the opposite directions. No huge surprise, no waves involved. Anyway. I mean, you're obviously new here, Josh. I have 1,000 videos. I have explained all of this hundreds of times. I have the website link below. I have the simple overview videos below. They will explain to you that there is no need to wave anything. Everything's bullets at a frequency. That's the electromagnetic spectrum. It's just bullets at a frequency, not a wave of anything. Plots voltage. What is this? Isn't even a proper way to start a sentence. Plots voltage versus time graph, and you'll see a wave pattern. So what? That doesn't mean the thing is a wave. I just explained that I could build something. I could throw baseballs, and you could do you could draw a chart, and the chart would go, hey, look, there's a lot of baseballs, there's no baseballs, a lot of baseballs. I can make it look like a wave. It's not a wave. I mean, you know, just because you put in all these extra little lines doesn't mean those extra lines exist. You know, when you do your little sine wave thing, where's the evidence of any sine wave? There's just peaks and valleys. Peaks and valleys. It's on, off, on, off, on, off, on, off. A lot of photons, no photons. A lot of photons, no photons. I mean, I can vary how much I throw of something too, right? So let's say I was throwing baseballs, and I could throw 3 in 1 second, and then I could slow the pattern down to 2 in a second, and I could slow the pattern down to just 1 every second, and I would end up with a frequency inside a frequency inside of a frequency, and it would end up being one big wave you could draw it as, right? Or you could do the individual spikes. There's lots of ways you could plot it, but I wasn't waving anything. Whatever. I'm just saying, you know, you want to believe that the photon is some perturbation in a fake medium. Okay, go ahead and believe it. I can't stop you. I'm just saying there's nothing about what it does, as Feynman points out. I mean, Feynman concedes there's nothing. Photons don't do anything wave-like. They don't spread. They don't diminish over time and distance. They don't do anything waves do. They do exactly what bullets do. They go from point A to point B and smash into something. So you want to believe it's a freaking wave? Go ahead and believe it. But I'm just saying it's not. I'm saying there's no evidence it is, and quit pretending that you have some big pile of evidence that demonstrates that there's any such thing as a fucking electromagnetic wave, that there's any such thing called an electric field and any such thing called a magnetic field. These fields do not exist. I don't need this bullshit. Connect alternating current to an antenna. Again, how is that waving? It's shooting photons. Do you understand? The antenna produces photons, all right? Like light, corpuscles. They're not fucking waves. They're bits of energy. It produces a bunch of energy, then a bunch of energy, then a bunch of energy, then a bunch of energy. A bunch of little BBs fly off the antenna. Then it goes silent. And then the antenna shoots a bunch of BBs again. You can't understand how it's that frickin' fucking simple? I just explained how it works. I explained how it works 5 minutes ago. I explained to you the antenna sits here. You shoot energy into it, little bits, right? And the little bits expand the atoms blow little bits out at the same frequency you're pumping them in. So you pump in a bunch of little bits, the little bits fly out of the antenna. What's complicated? They're in all directions. That's it. A bunch of little bits fly off, and at the inverse square law, they radiate, just like by Maxwell's equations. Maxwell equations, again, are just lines, radial lines. That's how the force leaves, radial lines. If you're close, you get hit by more because there's more lines you're interfering with. And the further away you go, there's less lines. Therefore, you get hit by less of the little bits. No wave involved. No fluid, no substance, no need for perturbating anything. I mean, the fact that they draw antennas and they just show lines. So again, this is where, cognitively, I was never fooled by the lines. I didn't say, oh, because there's lines, that's like dropping a rock in water and the water ripples. No, that's not what's happening. The antenna is being vibrated, or you could argue expanded. And that's the simple. It's just being expanded. You shove force in, it expands the antenna. And the same thing when it's collecting it. All right, then how come people who make radios, amazing, build it and works using the idea of waves? It's just a lie. There's absolutely nobody sits there and has to use waves to build a radio. Nobody ever. I built them. I didn't need it. I didn't need wave science to understand how electricity works. Oh, shit. Electrical engineers don't believe what you believe. Okay, so, and if they believe in God, I'm supposed to believe in God too. I mean, it's just amazing. Amazing. So that's resorting to the argument from authority, which is a bullshit argument. It's like telling me what the Pope believes. Right. I'm the one pointing out how, again, so if the electrical engineers, if Feynman told them light's not a wave, it's a corpuscle, they would say to Mr. Feynman, you're full of shit, Feynman. I build radios. I know better. Is that your argument? Feynman was an idiot. He was wrong. I mean, that's it. See, he's the god of your bullshit. That's the irony of it. And you people won't even concede that he didn't buy the wave bullshit. His Feynman diagrams, by the way, don't have any waves in them. They have vectors. Electron moves this way, photon goes this way. All vectors, no waves. Well, I'm just pointing out to you, I mean, I've played the lecture in a video, but go to his Auckland, the lectures he did in Auckland, in the second lecture, I think it is, he clearly says, look, it's a corpuscle. It might even be in the first lecture. He says it. It's a corpuscle. All right? Newton was right for the wrong reason. He says those exact words. All right? He says it doesn't do, there's no wave. It doesn't spread. It doesn't do all the things waves do. It's not a wave. So again, you want to tell me Feynman lied at the lecture? Fine, go ahead and say that. But say it directly. Say he was drunk that day. Where? Show me a Feynman diagram with a wave in it. No waves in Feynman diagrams, all vectors. All angles. Angles, angles, angles. No waves. If you think the squiggly line he's drawing is a wave, no, that's just the symbol he's using for photon, shithead. It's not a wave. It's a symbol. Oh. Oh, these people, it's religious nuts. But yeah, so that's why I have to hit this subject a lot more, because this really is how people think. I mean, they are so stuck in this completely upside down back assward perception of this stupid soup that the universe is in. You know, that the universe is perpetuating in soup and making magical noises somehow. I mean, look, why don't you show me where a photon interacts with something passively? That is, it just goes past it, and the photon continues undisturbed, and it just wobbles something somehow or something. Never happens. There's no fields. There's no bullshit. A photon either hits something or it misses something. There's no in between. You come across like a fucking pompous douche. Who the fuck are you, shithead? You come across like a pompous, sarcastic, hypocritical, I don't even know what that word is, eugenist. But maybe that's just me. Yeah, it's just you. Fuck you. Everything has to be argued. People are arguing and saying, we say it's a wave because all the people who make radios say so. Well, first off, all the people who make radios don't say so, so you don't even have that as proof. Okay, and frankly, it's an irrelevant argument. It doesn't explain why photons are waves. It doesn't show evidence of why they're waves. Look, there's no link you'll ever find of Feynman talking about photons as waves. I just told you, look up the Auckland lectures, New Zealand. Type in New Zealand and Richard Feynman. You'll get the lectures. He's wearing a nice brown suit, okay, with the chalkboards and everything. All right, 1981, I think they were made. All right, and he says the words overtly. You mean a guy. You are a mean guy. What? Who cares? You either can make arguments or you can't. That's how yes, that's me. Okay, either make an argument or just shut the fuck up. Because everything else is useless. This is talk physics. It isn't talk whiny bitch. It isn't, I don't like the way your nose is. It's crooked. No, it's talk physics. Make a physics argument or fuck off. YouTube this. Feynman explains light of EM spectrum with a GAT explanation. Well, I'm just saying I've seen every video Richard Feynman ever made that's on YouTube. Any presentation done by Richard Feynman I have seen. So there is no place where Richard Feynman says light's not a corpuscle. Light's a wave. Except in some indirect way where he might do it just to make public jargon. I'm saying when he's pushed to explain what photons are, look, you know what I'll do? I'll go get the video and I'll play it again just for my own entertainment then, right? I'll just rub it in your nose overtly again. I mean, he was being as unambiguous as he could be. He said directly, I wish They didn't teach physics students that photons are waves. He said it. I'm not looking at it now, you asshole. I told you to go look at the fucking lecture. Damn. But like I said, yes, just to get back at you, I even though I have made videos previously playing Feynman, okay, I'll do it again. Just to keep pointing out the fact that Feynman didn't believe in your ether. Feynman believed the universe was functionally random. He didn't believe it was random wave interference crap. He believed things came out the way they did because the universe itself decided those probabilities, not because of some stupid Huygens wave interference. What video did you send me, you retard? I don't think you ever watched the video I sent you. What video are you talking about? And again, why don't you just point to the evidence? What evidence do you have that photons are a wave? The two-slit experiment, which demonstrates nothing because the single slit says exactly the opposite. The fact that there is a pattern can be explained as what it is, angles. Okay, photons go to specific angles. The wave in photons isn't even a wave because it's light, dark, light, dark, light, dark. It doesn't get gradually light and gradually dark like it's supposed to. But what else do you have? Besides that stupid pattern, the simplest pattern in the universe, by the way, on, off, on, off, on, off. Besides the simplest pattern in the universe, what evidence do you have that photons are a wave? Just watched it now. It'd be good content for your stream. I don't even know what you're talking about. So this is useless rubbish. Just watched it now. What did you watch? No, I'm not watching it now, asshole. Fuck you. You're not setting the agenda of my life. Frankly, it's not even a scientific way to do something, right? If you're making an argument, I have to listen to it, okay? I have to watch it, see it in context, not react. You don't react to something unless you're just something's complete crap. Well, yeah, then you'll go and just sit there and look at it, and because you're just joking. You're just I mean, I could go to any religious video and I know I don't have to pay any attention because it's going to be absolute rubbish. But let's assume that you have some point to make here. What I'm going to absorb the information in a live stream, right? Fuck you. But like I say, I will be happy to replay Feynman's lecture, the important part. I haven't seen him in a while, might as well. It'll be fun. Feynman was a probability guy. He wasn't a wave guy. Right, but this is, like I said, this is the core stuff. Because it really is these ether crap. You can't have a rational conversation with any of these people until you get rid of these stupid notions that the universe has to be made out of glue and stuff is the simplest thing in the universe is somehow perturbating waves off of it in all directions, and somehow those are influencing something without influencing it at all. Yeah, by magic. Well, it wasn't anywhere near a great debate, but yes, probably is time to go. Cut some grass. But anyway, till the next, I'm just saying, just all these core issues really have to be, if you can't fix that, then you can't have a conversation because people's minds are too closed. But Jesus is God. Jesus is God. Wave, 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 wave. Ether, ether, perturbation. Hyperberloid, hyperberloid.